1 plus epsilon means it contains set of all real numbers in between. Yes. How many real numbers are there? Infinitely many are there. Among them, 1 is a natural number, it is also a real number. But this total interval is not contained in the natural numbers, because natural numbers does not contain decimals. N does not contain decimals, but 1 minus epsilon and 1 plus epsilon contains rationals, irrationals, decimals, everything. When do we say one set is subset of the other set? If every point here is a point here, then only we say it is subset or contained. But because this is not contained in N, we say that N is not in the neighborhood of 1 and 1 is not an interior point of 1. 1 belongs to N. 1 is there in N. If 1 is there in N, how will we write 1 belongs to N? 1 belongs to N does not mean 1 is interior point. We cannot say. Interior point means not only 1 is there, in and around 1. 1 minus epsilon to 1 plus epsilon. What is epsilon? A very small positive real number. Around 1, this small interval that is containing infinitely many real numbers, all these real numbers should be present here. But we cannot say that because this is not containing decimals. Therefore, we say N is not in the neighborhood of 1 and 1 is not an interior point. Similarly, N is not a neighborhood of 2. 2 is there in N, but N is not in the neighborhood of 2 and 2 is not an interior point. Why? Because 2 minus epsilon and 2 plus epsilon, if you take, is not contained in it. Because 2 minus epsilon, 2 plus epsilon again contains infinitely many real numbers. In place of P, we are having 2 now. 2 minus epsilon, 2 plus epsilon. In between 2 is there, but many real numbers. That means real numbers means it includes decimals. Here decimals not there. So this is not contained. So 2 is also not interior point. 3 is also not interior point. N is not in the neighborhood of 1. N is not in the neighborhood of 2. N is not in the neighborhood of 3. So N is not in the neighborhood of any of its points. Because P minus epsilon, P plus epsilon is not contained there. Not contained in N for all. Not belonging to, this is contained. This simple. Now R is in the neighborhood of every point. Why is it so? Because if you take any real number, what is one the real number system? Yesterday we have discussed minus infinity to plus infinity. This is what is called total real number system. If you take any point, any real number, then what is the neighborhood? P minus epsilon and P plus epsilon. This interval contains infinitely many points. This is totally contained within this. So this interval is totally contained within this interval. Therefore, we say that this any point which is inside is an interior point of R. For example, your P can be 1 by 2. If your P is 1 by 2, then what is the neighborhood of 1 by 2? 1 by 2 minus epsilon, 1 by 2 plus epsilon. So, in and around 1 by 2, there are infinitely many real numbers. But all these real numbers, they are part of this total. This R means this total. So this part is there in this interval. Therefore, we say for any point you take, automatically it will be within R. Hence, we say every point of R is an interior point. And we can say that because the condition P minus epsilon and P plus epsilon is contained in R is satisfied, we can say real number system is in the neighborhood of every point R. You can also say every P is an interior point. That means every point of R is an interior point and R is in the neighborhood of every point. Next, rational number system. Is Q in the neighborhood of any point? Answer is Q is not in the neighborhood of any real numbers. So we have defined yesterday rational numbers also. So here rational numbers means which are of the form P by Q, where Q is not 0. Irrational means which are not having perfect roots, root 2, root 3, root 4 and so on. So here we say that this open interval, if you take any number, any rational number, then when you take the neighborhood p minus epsilon and p plus epsilon, what is rational number means which can be written in the form p by q. For example, 1 by 2, 1 by 3, they are all rational numbers. 2 can be written as 2 by 1, so 2 is a rational number. 1 can be written as 1 by 1, 1 is a rational number. So anything which is in the form p by q, where p and q are integers, is called rational number. We cannot say root 2 as rational. Why? Because root 2 is root 2 by 1, but root 2 is not integer. So not only it is in the form p by q, p should be an integer, q also should be an integer. But if you take root 2, it is in the form root 2 by 1, but root 2 is not an integer. Therefore, we say that this p minus epsilon and p plus epsilon, this open interval, contains infinitely many real numbers. I told you, whenever there is a gap, within the gap, there will be infinitely many real numbers. Real numbers means it includes rationals as well as irrationals. Because what is real number definition? Set of real numbers means it includes rationals as well as irrationals. So within this interval, it contains not only rationals, it contains irrationals also. So we cannot say this is contained in Q, we cannot say. Why we cannot say? When do we say this is contained in this? Every point here is a point here. So whenever you take an open interval, it contains reals. Reals means rationals. Not only rationals, it contains irrationals also. But this does not contain irrationals. Therefore, we say that P is not an interior point and Q is not in the neighborhood of what is P? Any rational number. Therefore, we can say that no rational number is an interior point and Q is not in the neighborhood of any of its points. R is in the neighborhood of every point, but Q is not in the neighborhood of any of its points. That's what we have said. Because this contains irrationals also, rationals, irrationals. So, but irrationals are present here which are not there in this. So we cannot say it is contained. Hence we say Q is not in the neighborhood of any of the points, and we say there is no point of Q is an interior point. Next is Z. Z is not in the neighborhood of any P. What is Z means here? We have discussed yesterday. Z means here it includes 0 plus r minus 1 plus r integers, includes negative, positive, everything. Now Z is not in the neighborhood of any of the points. That is p minus epsilon and p plus epsilon is not contained in Z. Why is it so? Because if you take any integer, 1 minus epsilon, 1 plus epsilon. This is the neighborhood of 1. It is not contained in Z. Why is it so? Z contains only integers, but 1 minus epsilon and 1 plus epsilon, open interval means it contains not only 1. In between 1 minus epsilon, 1 plus epsilon, 1 is there, correct? In between them, 1 is there. But in between them, 1 is also there. But not only that, it contains decimals also. So it contains infinitely many decimal points which are not there in Z. Therefore, we say that Z is not in the neighborhood of any P, and no point of it is an interior point. 1 is not interior point, 2 is not interior point. 1 belongs to Z, correct, but 1 is not an interior point. 2 belongs to Z, correct, 2 is not an interior point, and so on. Next one, 1, 2, 3, 4 and so on up to n. If it is and so on, it is natural number. If it ends with n, it is finite set. It is not in the neighborhood of P. Why is it so? Because if you take again P belonging to this, P equal to 1 for example, 1 minus epsilon, 1 plus epsilon is not contained in S. Because 1 minus epsilon, 1 plus epsilon, open interval contains decimals also, rationals, irrationals, decimals, everything. But S contains only selected numbers. So this cannot be contained in this. Therefore, finite set is also not in the neighborhood of any of its points. And no point of this is an interior. Next one, every open interval is, when you compare to open interval means all the real numbers in between A and B. So what is open interval? How did we define that? This is A, this is B. So all the points in between A and B, and A is not included, B is not included. then it is what is called as open interval A comma B. So if you take any point in between open interval P, if you take in between, then P minus epsilon and P plus epsilon, this contains infinitely many reals. This is totally contained within this. Therefore, we say that this every point of the open interval is an interior point.
That means
Not only that, open interval is in the neighborhood of every point. So, this every point of P is an interior point, and second thing is this open interval is in the neighborhood of each of its points for all. So next one, P minus epsilon, P plus
Ma'am,
epsilon.
can you say once again, ma'am, for P
belonging
open
to
interval?
open interval AP means what? It is in between. When it is in between A and B, when P belongs to A comma B, open interval.
It contains real
it contains real numbers. Everything. Whenever open interval means it contains reals. Reals means rationals and rationals. If you take P minus epsilon and P plus epsilon, in this every element, is it present in this or no? So AB open interval means it contains all reals. This also is containing all reals, but every point here is within this interval. Therefore, we say that every point of AB is an interior point, and open interval is in the neighborhood of each of these points.
Okay.
For Fauzia, you also asked about this one, is that not?
Yes, ma'am. Clear, ma'am.
Now clear. Next, if P minus epsilon, P plus epsilon is totally contained in S, what is the meaning? If every point here is a point here, then S is said to be in the neighborhood of P, and P is called as an interior point. That's what I have been explaining. Now, the set of interior points of the set is denoted by S interior. This circle means symbol for interior. That is, there are a set of all the interior points is denoted by S. Now, if S is closed interval, what is meant by closed interval? It is containing A and B.
End point.
Earlier we have defined a closed interval
And
nothing
in between points.
in between. So set of all real numbers, including A, including B, and in between also. Open interval means containing only which are inside open interval. A is not there, B is not there. But if you include A and B also, then it is what is called as closed interval. So we want to know what are the interior points in the closed interval. So how to know whether what are the interior points? So let us take a P belonging to closed interval AB. So P belongs to closed interval AB means what are the options you are having? P may be equal to A, number 1. Number 2, P may be equal to B, end points, because closed means end points are segregated. Number 3, P is in between A and B. In between A and B means open interval. So P equal to A, P equal to B, P is in between. Then in that case we want to know, is A an interior point? How to know whether A is an interior point of the set AB or not? Here what is the set? Closed interval AB. This is the set S. So this is A, this is B. Closed interval AB. This is set S. Set S means all real numbers in between A and B, including A, including B. So if I take P equal to A, if I take P equal to A, I want to know whether it is an interior point or not. How to check? Whenever P equal to A, consider P minus epsilon and P plus epsilon. P equal to A, that means A minus epsilon, A plus epsilon. A minus epsilon will be left side of A plus epsilon will be right side of A. We want to know whether this interval is contained in this set S. Again I will redraw. What is the set S here? Closed interval AB. So every interval is regarded as a set. Yesterday we have discussed that. Every interval is nothing but set of real numbers containing A, containing B, closed interval in between also. The set here is given to be AB. Now we want to know whether P is
Charging.
Is it an interior point or not? How to check whether anything is interior or not? We have to check whether A minus epsilon and A plus epsilon is contained in AB or not. But if you take this is A, this is B, This is closed interval AB. This is the set S. Set S means it includes all the numbers in between A and B, including A, including B. Now we want to know whether A is an interior point or not. How do we check whether A is an interior point or not? If you take an open interval in this, it is A minus epsilon and A plus epsilon. P is equal to A. P is equal to A means what is P minus epsilon, P plus epsilon? A minus epsilon and A plus epsilon. Now when you take this open interval, the question is, can we say this total, is it within this? Which total, can you say it is within this? Can you say this? No. Part of it is inside, this part is inside, but this part is outside. This part is inside this interval, this part is outside this interval, it's outside. But according to definition, when do we say it is an interior point is, it should be totally within this set. But this is not totally within this set, therefore we say that A is not an interior point. Why A is not an interior point? Because A minus epsilon and A plus epsilon is not totally contained in this. A part of it is inside, this part is inside. Inside AB, this part is there. But this part, A minus epsilon to A, within this gap, how many real numbers will be there? Whenever there is a gap, there are infinitely many real numbers. So in between A minus epsilon to A, there are infinitely many real numbers, but these real numbers are not there within this. A part of it is inside, a part of it is outside. Therefore, A minus epsilon and A plus epsilon is not contained in S. Therefore, we say A is not an interior. And S is not in the neighborhood of A. A is not an interior point. Yeah.
A point is a neighborhood. If it is a point is a neighborhood, that is also a interior point. That can you can say interior point. Huh?
What is interior point again? We are going back to first one. So P minus epsilon, remember always this definition. P minus epsilon to P plus epsilon, whenever it is contained in S, S is in the neighborhood of P or P is interior point of S. Both means. So here A is not an interior point and S is not in the neighborhood of A. Why S is not in the neighborhood of A? A is there in S. A is a point in S. A belongs to S. A is there in S. But it is not an interior point. Interior does not mean inside. That is English meaning. Interior means inside. Mathematics definition is inside. Interior means open interval. P minus A minus epsilon and A plus epsilon. This total should be within S. This total is within S only. We say this A is an interior. So a part of it is inside, a part of it is outside. We cannot say A is an interior point. We can say A belongs to S. Belonging to is different. Interior point is different. So we can say A belongs to S correct. In TIFR paper, Serenya, you are writing I think so TIFR for integrated PhD. A belongs to which of the following are true and false? Definite questions in TIFR. And in JAM paper also, which of the following are true? A belongs to AB, correct. Is it true or not? Correct. But A is not an interior point. Why it is not an interior point? Because A minus epsilon and A plus epsilon, this is not totally contained in this. A minus epsilon, A plus epsilon is not within this. A part of it is inside, part of it is outside. Therefore, we say S is not in the neighborhood of A. That's also correct. A is not an interior. Both the statements are correct. Here three statements are correct. What are the three statements that are correct? A belongs to S correct. S is in the neighborhood of A correct. S is not in the neighborhood of A correct. A is not an interior point of S correct. Therefore, very important is belonging to concept is different. It is inside-ish. Similarly, B is also not an interior point. B belongs to this set, closed interval. Because closed means B is included. But B is not an interior point. Why? Because if you take again, how to check whether it is interior point or not? Around B we have to take neighborhood. That means B minus epsilon, B plus epsilon, open interval. In this, is every total part is it within AB? So can we say this total part around B, can we say it is within AB? This is B, this is A, this is the set. This is the set as, please mute yourself. Now, if you take B, in and around B, we have B minus epsilon and B plus epsilon. This is B minus epsilon, B plus epsilon. This open interval contains infinitely many reals. This total part, it is not within this. A part of it is inside, a part of it is outside. Therefore, we say that B is not an interior point. B is not an interior point because this total interval is not within this. Part is inside, a part of it is outside. Therefore, we say that B is not an interior point. And we say that S is not in the neighborhood of B. So here A is not an interior point, B is not an interior point. Now, how about any point in between? Because closed interval means A, B, anything in between A. So A is not an interior point, B is not an interior point. But if you take any point inside, then the open interval P minus epsilon and P plus epsilon,
Yes, it
if
is
you
indeed.
take it is inside this AB or not, whatever may be P minus epsilon and P plus epsilon is inside this AB. Therefore, we say that this every point in between AB is an interior point. So, whenever you take P in between AB, automatically it is an interior point. It is equal to A, not an interior point. It is equal to B, not an interior point. But in between A and B, every point is an interior point. Therefore, what are all the interior points of this set S are? Every point in between A and B is an interior point. Therefore, what is S interior? If S is closed interval, remember this as formula. S
Open interval.
interior is open interval. Suppose in the exam you are given what is the interior of 2, 3. If S is 2, 3, what is S interior? Then you need not do all this nonsense. Directly remember this as formula, open interval 2.
Open interval 2, 3.
And suppose you are given S is equal to,
Ma'am, if S is open interval, ma'am.
open interval also it is open only. We have seen earlier. So
Sir,
write
comma.
down this point. Write down this point. All of you, please take down this point. Shortcut. It is not there in the document. You have to take down the notes. If S equal to, note down this shortcut. If S is equal to AB, open interval, then every point inside is interior. So S equal to AB. Then write down this. S interior is AB. For open interval, every point is interior point. So S interior is also AB. How the question comes in the exam? Emma, Harish, are you in this meeting? Harish, are you in this meeting? Saranya, Ashwini,
Yes, ma'am. Yes, ma'am.
following.
Yes, ma'am. Yes, sir.
Joint exam. So here S interior is here. S is open interval, S interior is. So what is the shortcut for this? Example, write down this. For example, if S is equal to -1, 1, open interval. If S is equal to -1, 1, then S interior is equal to -1, 1. For open interval, interior is open interval. Next, point number 2. If S is equal to closed interval AB, if S is equal to closed interval AB, second, point number 2. S is equal to closed interval AB, then S interior is open interval. So for closed interval also, interior is open interval. If S is closed interval, S interior is open. For open interval also it is open interval. For closed interval also it is open. Now, example. For example, if S is equal to, put down this one. For example, if S is equal to 3, 4, or shall we take fractions? 1 by 3, 1 by 2. Then S interior is, we can have integers, negative numbers, fractions, anything. Open interval, 1 by 3, comma 1 by 3. So for closed interval also, interior is open interval. For open interval also, S interior is open interval. Next. So AB is in the neighborhood of all the points except A. That's clear. Next. Give an example of a set which is in the neighborhood of each of its points. What is the example? Open interval AB and R also, real number system. It is in the neighborhood of each of its points. Open interval, every point of it is an interior point, and R is also in the neighborhood of every point. Next, example of a set which is in the neighborhood of each of its points except one point. One point means semi-closed. So end points are never interior points. So take down another one. If S is equal to, take third shortcut. If S is equal to left closed, right open. Left closed, right open. That is semi-closed. So this end point A is not an interior point, because whenever end points are there, whenever you take a neighborhood, part of it will be inside, part of it will be outside. So end points can never be interior points. So A is not an interior point, but everything inside is an interior point. Here we need not check for B because B is not included. But A is included, A is there in us, but A is not an interior point. B is not there in us, we need not check. And in between this, every point is an interior point. Therefore, what is S interior? Open interval. Note down this third example. Semi-closed. That is left closed, right open. Then S interior is open interval. So for closed interval also, open interval AB. For semi-closed also, you open interval AB. For open interval also, open interval AB. So what is here? Example for this.
For any interval?
For any, okay, take the example for this. Just write below this. Later you will understand. If S is equal to, for example, if S is equal to -1, comma 2, open, for example. S interior is, what is S interior? -1, comma, open. Left closed, right open. What is S interior? Open interval, -1, comma. For semi-closed also, this is open interval. All of you, did you take down this? Can I go to next? So, next. Next one. One more. Take down fourth one. If it is number 4, if S is equal to open at A, closed at B. Open at A, closed at B. What is the meaning? In this, A is not included, but B is included. Every point inside is included. But you know that B is a point in the set, but it is not an interior point. Why it is not an interior point? Why? Because b minus epsilon and b plus epsilon is not totally in this. A part of it is inside, part of it is outside. Therefore, b cannot be the interior point. Everything inside is an interior point. So, what is S interior for this? Open interval. So, for left open, right closed also, S interior is open interval A. Is that clear, ma? So, for semi-closed, closed, open, for all the cases, for any interval in general, S interior is open interval. This is the concept. Remember this as shortcut now. Okay. Next. Give an example of a set which is in the neighborhood of each of its points except one point. Except one point means end point. A is not an interior point, semi-closed. This is also an example because every point of the set is an interior point except so except one point, end points, remaining all are interior points. Okay, next. Set which is in the neighborhood of each of its points except 2 points is closed interval. Because whenever it is closed interval, every point inside is an interior point, but A is not an interior point, B is not an interior point. Therefore, 2 points are excluded. Every other point inside is an interior. Up to this clear, mo? So you will have the question comes in the exam. Which of the following are examples of the sets which are in the neighborhood of every point except 2 points? Like that option will be asked. So you know that set means it is an interval. So you can record it as set as well as an interval. So an interval which is having every point of it is an interior point except 2 means closure. Like that. Next one. A set which is not in the neighborhood of any of its points. Example is natural number. Z, Q, let us see. R minus Q, this total, finite set. I have explained earlier, no point of N is an interior point, no point of Z is an interior point, no point of Q is an interior point, no point of R minus Q is an interior point, because whenever you take R minus Q, that means irrational. Irrational means, for example, root 2. Root 2 is irrational, then root 2 minus epsilon, root 2 plus epsilon. This open interval contains reals. Reals means rationals as well as irrational. So it is not contained in R minus Q. Because R minus Q contains only irrational.